Assalamualaikum guys. I am Mohammad Afan bin Amir, AWS Student Builder Group Leader at University Karachi. तो बेसिकली मैं फरवरी 2026 से फरवरी 2027 के लिए AWS का रिप्रेजेंटेटिव हूँ बहरिया के अंदर। एंड ये मेरा एज एन AWS हेड पहला इवेंट होगा। काफ़ी 6-7 महीने से हमारे कोई लास्ट इवेंट नहीं हुआ, तो हमारे पहला इंट्रोडक्टरी सेशन है जिसमें हम बिगिनिंग से सब कुछ स्टार्ट करेंगे कि बेसिकली AWS क्या होता है, क्लाउड कंप्यूटिंग क्या होती है। तो हमारे टॉपिक्स हैं, तो हमारे दो स्पीकर्स हैं। एक हमारे मोहम्मद सुलेमान जो हमारे वाइस लीड है AWS स्टूडेंट बिल्डर ग्रुप बहरिया के, 2 टाइम्स AWS सर्टिफाइड भी हैं। और दूसरे हमारे हैं मोहम्मद अली, सोल्यूशंस आर्किटेक्ट हैं क्लिक हाउस के अंदर। 20 ईयर्स का इनका इंडस्ट्री का एक्सपीरियंस है, ग्लोबली काम करते हैं और मेलबोर्न में बेस्ड है अभी ऑस्ट्रेलिया में। सुलेमान नेक्स्ट स्लाइड। हाँ, तो हमारा एजेंडा है, पहले इंट्रोडक्शन होगा, हमारी जो टीम है इंट्रोड्यूस करवाएंगे जो हमारी सेलेक्टेड टीम है। उसके बाद आपको ब्रीफ सा पूरा इंट्रोडक्शन दिया जाएगा कि AWS स्टूडेंट बिल्डर ग्रुप्स होते क्या है, इनके ऑब्जेक्टिव्स क्या हैं, इनमें आप आओगे तो आपको क्या फ़ायदे हैं मीटिंग अटेंड करने के, सेशन अटेंड करने के, मतलब पूरा ब्रीफ से इंट्रोडक्शन होगा। उसके बाद हम आपको इंट्रोडक्शन कराएंगे क्लाउड कंप्यूटिंग का कि वो क्या होता है, इस AWS के फंडामेंटल्स इसमें क्या क्या है। और हाँ, sure. So we'll start with an introduction to the team, and then we'll go towards what are AWS Student Builder Groups and what are our objectives, what are our missions, and what benefits will you guys get if you be a part of the sessions. Then we'll move forward with introduction to cloud computing, role of AWS in cloud computing. Then we'll go towards builder's mindset and how you can get towards AWS certifications. Later on, Mohammad Ali will join us and he'll share his industry insights, his experience in working in global firms like AWS for about 7 years. Then we'll have a Q&A session, and then we'll have a community announcement. So, next slide, please. So basically, Abira Amir is our mentor, AWS Student Builder Group. She was a past leader of AWS Student Builder Group for about 2 years now. I am Mohammad Afan bin Amir. I am the current representative at Bahria University. Mohammad Suleiman is our vice lead, and Syed Taha Hassan is the general secretary. Next slide. Then we have Daud Khurram, who will be leading the media, photography, reel shooting, videography stuff. So Alifia handles all of our social media postings, our digital marketing, etc. SN is our graphics head. Waqas is our development head. All the development websites, our competitions will be led by Waqas, and Huzefa is our operations head. He'll be covering on all the on-site operations. So what are AWS Student Builder Groups? So basically, AWS Student Builder Groups are a new term. Previously, we were known as AWS Cloud Clubs. So what's the difference? Well, previously, we were limited to teaching cloud only to the community, to the participant, to the members. We only used to teach what is cloud computing, what are AWS and how is it used in cloud, etc. But now we have rebranded, we are transitioned into a new club. Our objectives have changed. We are now teaching technology, not just cloud. We will be teaching agentic AI, we will be teaching machine learning, front-end development, back-end development, and all sorts of tech-related domains come under us. So basically, we are a student builder group leaders. We do not have any sort of faculty involvement. We are led by students and we are governed by AWS itself. So that sets us apart from different societies that you see in the different universities, because we are a globally recognized society and we get all our events, our materials, our resources, etc. from the AWS itself. Our mission is to create an environment. You can move on now. I've told most of the stuff. So these are our past events that have been international in the world. They have been in Africa, US, in our same Karachi. We have also have previous events itself in the AWS Cloud Clubs. So these are just representations. So why should you guys join us, be a part of the events? Why just not stick to the curriculum itself? So the thing is, when people join university, they are most of the time the target is getting GPAs, getting good grades. But in the meanwhile, they forget that about only 10% to 15% of what is being taught in university is being implemented in the industry. So joining our clubs gives you an insight and introduction, networking to the industry itself, so that you learn skills that are not being taught in the classes. We have hands-on learning opportunities, like we provide proper workshop, proper environments. You do not need to buy custom environments, and we'll properly guide you with project-based learnings. We'll guide you with the industry exposure. And when you join a community, it's like you learn the teamwork, how to grow together, how to manage teams, how to lead, etc. These factors play an important role when you're applying for jobs, because they see that you have the experience of working in a teams, not like that you are a solo person who does not interact. So these sort of things give you a bonus impact on your resume as well. Now, I'd like to call Mohammad Suleiman to continue forward with what is cloud computing, it's all of these basics, and what is AWS, etc. He'll take over now.
Okay, so Assalamu alaikum. My name is Mohammad Suleiman, Vice Lead of AWS Student Builder Group Bahria. So I'll be talking about what is cloud computing. So cloud computing, in simple words, is the delivery of computing or slash IT services over the internet, such as uh, compute storage, databases, networking, and analytics. So instead of owning physical infrastructure, anyone in the world can access technology or these IT services on demand, along with the facilities of flexibility, scalability, and cost efficiency. So as you can read right here, there are several key advantages of this scalability. If you are if you are hosting an application that is meant to serve 1,000 users consecutively or at one time, and suddenly your demand starts growing. So you could just with a few clicks or with a few commands of the cloud on the cloud console, you can just easily scale up your infrastructure to serve more than 1,000 users. So pay as you go pricing model, it usually follows a pay as you go pricing models. It means that you only have to pay for how much you use. You do not there's no fixed pricing that you have to pay for 1,000 users or 100 users. You just pay for the overall usage. So it is globally accessible, highly available, and it enable teams to innovate at a faster pace without worrying about the technological or infrastructure limitations. So I will also explain about the cloud deployment models. So first of all, we have public cloud. These are just companies like AWS, Azure, Google Cloud. Anyone can just approach them and use their cloud services. Private cloud is dedicated cloud infrastructure for single organization. There are some companies, especially in Pakistan and worldwide, that they don't want to move on to public cloud. It could be due to compliance, regulations, and could be of due to any reason. So they prefer to use their own in-house infrastructure as a cloud. So they are called private cloud model. In Pakistan specifically, if you look at Dawood Industries, they have their own private cloud. They maintain their own data center, and you have a third thing called hybrid cloud. So it is combination of public and private environments working together. So supposedly, as I have told you earlier, that many companies have to face enforce compliance and face they don't go against the regulations. Could be of the government or could be of the public public data. So what they use is they combine um, both things. They use public cloud and private cloud as well. You can say that they uh, they use a service of AWS such as EC2 to scale their application, and they could use their own in-house servers to store the data. So we would talk about the service model. So infrastructure as a service. So in this service model, you of the cloud, you just have to you get a service that gives you access to the entire infrastructure of the cloud, such as Amazon EC2. On Amazon EC2, you are responsible for your own operating system, for patching it, for maintaining security updates and things like that. On platform as a service, you just get a service. define the cloud service provider that I need this sort of configuration, and already comes baked in. And software as a service are ready to use off-the-shelf applications over the internet, such as Google Meet. This is also an perfect example of software as a service, Microsoft Office, OneDrive, and so on. So road to AWS certification. So whenever you are starting in cloud or in some specific cloud vendor, you or go for certification because it serves as a structured learning path. So first is the AWS Cloud Practitioner. It is a relatively easy certification exam. If I can recall, it took me around 10 to 15 minutes to go through all the questions of the exam when I was giving this exam at a test center. So, and it involves no hands-on labs, but it is a best practice to build some sort of small projects so you can learn about the core AWS services, and it really tests challenges you to think about real world scenarios. So I want to talk about builder's mindset. So habits for success. You have to stay curious because the cloud industry is revolutionizing at a fast pace. Technologies are growing rapidly and at a very fast pace. So, and another thing is to build publicly. Whatever you build or create a small project, you should share it with others and embrace failure as learnings and collaborate with others. So I would like to hand it over to Mr. Muhammad Ali. He would.
Assalamu alaikum, Sir Ali. Are you there? So basically, Muhammad Ali, he did his bachelor's from Bahria University in about like 2004. Then he moved for master's in King Fahd University. Later on, he has been working in different global institutes, which include Futureware, ADCO, Dell EMC, Amazon Web Services, ClickHouse, etc. I think we are a little bit early in this because he was to join at 5. So Suleiman, can you go back to previous slides?
I am here. If you guys want me to start, that's okay.
Yes, sure.
All right. Hey, everyone.
Thank you.
No worries at all. How's everyone today?
We are good. How do you?
I am very well. Yeah. Guess what time it is on a Sunday night? It is 9:47 p.m. in Melbourne. So I'm based out of Melbourne, and I'm just gonna start a presentation in a second. And guess what? I've built this with AI. So let me just get myself going. All right. Let me know if you guys see my screen. Okay. Thumbs up.
Yes,
or
yes.
All right, perfect. All right. Hey, everyone. I am Muhammad Ali. I am from the same uni as you guys are. Most of you guys are. I'm not sure if everyone is here from Bahria University, but I used to be a student at Bahria University. We happened to be the first batch that started in 2000, the first batch of the BIMCS campus in Karachi. So yeah, and we were the first bachelors of software engineering. So I did my BS from Bahria, and then basically I ended up 21 years down the line in across the world in Australia. So I'll walk you through the journey that I had, because I was told, like, this is just for people to know, like, what I've done, even though I'm not, I don't feel myself highly accomplished, but I think I've done all right over the years to be able to, be in this position. So what we'll cover today is I'll walk you through my journey and why I chose AWS. I did work for AWS for over 7 years and learned a lot. and then I'll have some lessons for you guys who are getting going. Can I just get like an understanding of what is the distribution of attendees here? Are you undergrads? Are you in the masters, or are you guys graduated already? Can I just get like someone to unmute themselves and give me like the distribution?
Most of our undergrad.
Most of our undergrad. All right, perfect. Let me fix my mode because I think my headphone is not working. You guys can hear me all right, right?
Yes, sir.
All right, so I'm Ali. I have graduated in 2004, and then I happened to went to Saudi Arabia, and then UAE, and then Australia. 7 of those years out of those 21 years were in AWS. And when I ended my stint at AWS, I was a principal solutions architect, and then I left to a company called ClickHouse, which is an analytics startup, and I'll talk about ClickHouse as well in this presentation. Right, so that's my journey so far in my career. 2004, I graduated, and I joined a company called ITIM Systems. We happened to have competed in some of the programming competitions, like I forgot even the name, ACM programming competition, and we used to we came third and first in a couple of occasions. So that had me sort of in good position to get a job at ITIM Systems, who happened to have been at that time was a company was hard to get in. Like, you know, you always had these companies. I'm not sure what's a company today in Karachi or in Lahore in Islamabad happens to be that company that everyone wants to start join. Maybe Systems seems to be a popular name, but not sure about Karachi. What can I ask? Can I have this session be interactive? Which is the company you guys aspire to join after you graduate? Do you guys know some company in Karachi?
Like Folio 3, Systems Limited, Contour Software House. These are the big names at the moment.
Perfect.
Yeah, Atomics as well.
Perfect. So, right. So yeah, I also had like ITM System, which I thought they will never hire me, but they eventually hired me, and that's how I got my first job. And then I was building EPOS solution, which means you know, I learned Java in my undergrad, and then I started with .NET. But C# and Java happened to be very similar, so I was fine. I learned quickly, and I started building on C#. Then in a year after that, we happened to have worked in final year project on something that is called Documentum. So this is a good story for you to know that how your work in undergraduate could actually lead a career move later. So we have one of my friend's brother used to live in US. He came back for you know, how people who live abroad to come back to meet their families. He came one of those months he came back, and he spoke to us about what he does in the US, and he worked on a system called Documentum, which is basically a document management system, a content management system, which is essentially saying companies who run software or who run well, when you're running a company, there's a lot of documentation that you have to create, and large companies require the documents need to be stored in safe place, and those solutions are called document management system or content management system. So one of the document management solution, which was like a software that you could actually install it on servers and let your employees start loading your documents in it, was called Documentum. And we said, how about we actually use that, because that software could get us job abroad. It was, we were crazy. We were thought, we will be graduate students doing this thing, and we might just be able to hire ourselves into a company abroad. So that was basically the dream. So we started building on something, and our final year project was called ULife, which is basically university life. And then the idea was we built a solution for uni students to create documents like, the coursework and their project work and all of that. And we presented to our university's teachers, and they were quite surprised that we actually took industry software, we customized it, and we made it we made it look like it's for a university, not for a company. And we all got like A in that. And then after that, of course, that software was not used in Pakistan, so there was absolutely no scope. So we were just crazy doing that. And then, we learned a lot, but we ended up doing the same old thing, which is software development using Java and C#. In my case, it was C#. So we carried on with ITIM. But a year after that, someone actually saw the document we created in our final year project in Saudi Arabia. So we sent the docs over to Saudi Arabia, where this friend's brother was working. So one of the new companies there said, you know what, we're looking for engineers who know Documentum. So I got a call, and I interviewed, and then I got hired. And I was like, okay, I was supposed to be going to US because I was applying to university in US for master's. But then I said, maybe this could be a career, because uni was like in US was, weren't sure they will give me the visas or anything. So I chose to sort of start with a company called FutureWare. So that's how my final year project got me a job a year down the line. And I ended up this company called FutureWare, because this was a new company. They gave me, they gave me a lot of freedom. So I hired a lot of individuals from the local uni there called KFUPM, which is where I actually did also half of my master. I did not finish my master's. I'm a dropout from master. So, but I was doing really well in masters. I had like 4 GPAs or something like that. So basically, yeah, I hired a lot of people in KFUPM. After 3 years, I decided, like, you know what, I am very early in my career in management. So I decided, like, you know what, I need to be techie. So I resigned. I moved to Riyadh after that in Saudi Telecom. And then after a year, I went to a company called Dell EMC. Now, Dell EMC happens to be the company that actually built that Documentum software. So I came full circle into the company that built Documentum, because I built that in my undergrad. So undergrad work got me a job in Dell EMC. So it used to be called EMC. Dell acquired it later, but EMC was the largest hardware storage provider in the world, which basically means they used to build storage area networks, SANs, which essentially, what is a SAN? SAN is like a bunch of disks stored in a cabinet-like system and connected over the network to the server racks, which means you can store a whole lot of data in those systems. So enterprises would run a lot of SANs. So CMC was that company, and then that owned that Documentum software. So I joined a Documentum, basically Documentum as a Documentum consultant. So, and that made me travel across Middle East, and I traveled in Turkey, Africa, Middle East on my Pakistani passport. They would get me a visa because I knew the stuff. But anyway, after that traveling job in EMC, I joined Abu Dhabi Oil Company, and then I did more Documentum there. So until the point where I actually, it was 2014 that I said, you know what, enough of Documentum. There's a thing called Docker that was released at that time. And there's a thing called big data that was released at that time, or getting popular at that time. So I started doing Documentum, Docker and big data in my time at home. So by then I was married. So I would go back home and sort of, dabble with what is, big data, what is Docker, and all of those things. So that landed me a job back in Dell EMC. So I came back to Dell EMC as a consultant for big data, for Hadoop, Kafka, and the new techs at that time. So that's when I called it a day on Documentum. But Documentum served me from 2005 to 2014, 9 years that I worked. So that whole 9 years of my career was a final year project we started in undergraduation. So that just means that you could actually do something in undergraduation that actually can lend you or it can actually, take you places. And for me, it literally took me places. So yeah, and then I changed my track. I became a big data guy who's done Hadoop and all of this stuff. And then I joined Australia. So then I moved to Australia. Dell was a kind employer that actually moved me there. And then I left Dell because there was not a lot of big data work in Australia within Dell EMC. So I joined Telstra and ANZ, and 2018 is when I started at AWS, because and when AWS interviewed me, I actually had signed with the company called ANZ Bank. So I was supposed to not take the interview at AWS, but I called my friend and I said, it's the same friend who actually whose brother was in the US. So I called him and he said, what do you have to lose? You just go and interview at AWS. There's a big company. You will learn, how they interview and all of that. So because I really was not thinking that AWS would ever hire me, right? So I thought I'm not good enough for AWS because before then I did not do any cloud. So I did not spin up a single VM in the cloud. So I had no idea of the cloud. So I said, you know what? I'll present myself in the interview. I'm in there, rocked up without much preparation. I just said, you know what? I am joining ANZ next week. So what do I have to lose? So I just went in there, spoke my heart out. And the next week when I started ANZ, they called me and said, you know what? We might hire you. And I'm like, all right. So that's a big problem. So I had to tell my ANZ manager that, you know what? AWS is hiring me. And I really feel embarrassed to resign in the first 2 weeks. So that was a crazy moment in my career. But my manager was good. He said, you know what? You should go for it. But then I promised my manager that, you know what, I'm going to give you in return a project. So I delivered a project in 2 months before I joined AWS. And I told AWS that I need to finish something which I started here, which they hired me for. So I'm going to finish that and then join AWS. And AWS was a company that actually, in principles, was really good, like in a sense that they understood that, I had to do what I had to do for my employer. And then they waited it out for about 2.5 months before I joined. So I joined AWS, and that's pretty much took me to cloud. And at that time, I was like, you know what, this is good because cloud is everywhere. In Australia, we had the cloud. In UAE, we did not have the cloud data center of AWS. So it was a good time to join, cloud in Australia. Again, AWS was bigger than I thought I could actually handle. So I was ready to do anything. So I went all in, and I knew these skills which I learned are going to be useful for the rest of my career. So yeah, I started as a big data consultant there because remember I used to work as a big data consultant, which means I used to build software with high volume data, and they wanted me as the big data consultant. So I happened to be the first big data consultant in AWS. For professional services, which means they put me into projects and they said, go build things for our customers, which means I had to be building things and knowing things. So I learned on the job everything about cloud and everything about data in the cloud. So it was good. I had to, again, sort of push really hard myself to learn everything on the job. So it was crazy. In the AWS world, we say drinking for the fire hose. And for me, the fire hose was even bigger because I did not have any idea what cloud is. So yeah, I actually built a lot of data systems for many top companies in Australia, like Qantas, which is the largest airline here. I worked for 2 of the top banks here. I worked for Swimming Australia, and I built a system which Swimming Australia is basically the national team for swimming of Australia. And I worked with the national coaching team to help them collect the data of their swimmers. And there was a machine learning model we built that predicted who should go first, second, third, fourth in the relay races. And Swimming Australia happened to have won a lot of medals and a lot of data that they used to analyze and make decisions used to come out of the system that I helped build. So this was one of the highlight of the career. And then I moved to solution architecture role, which basically means, so this was time 2021. And before that, I need to also share that, I was a consultant and I applied for SA, which is seller role. SA is basically saying if a customer wants to, adopt AWS or use some technology from AWS, we were the people, or SAs are the people who tell them if it actually is going to work, how it's going to work, what is the design of the solution should it be, what is the architecture, best practices and whatnot. And that would mean a lot of communication with the customers. So I applied for this role. I was a hands-on guy. They said, you probably are a hands-on guy. You may not fit in this role. So I got rejected. And I waited it out 6 more months in. I said, I have done data enough that I can actually talk to customers and all that. So they onboarded me as a specialist analytics SA, which means I used to tell, I used to teach or help customers build or architect solutions, analytic solutions on AWS. And then I picked a software called OpenSearch, which is a service within AWS for search and analytics. And I became the SA for OpenSearch. And I had experience at Elasticsearch. OpenSearch is a fork of Elasticsearch, and I did 5 years in there, which was really good because we quadruple OpenSearch's business in terms of the revenue in AWS. And that also meant I spoke to 3 re:Invent in Vegas. I used to speak at summits in Sydney, Singapore, and whatnot. And then I also got promoted in there to an L7 role, which basically is a very high sort of position for an solutions architect in AWS generally. Yeah, so this was basically my AWS journey. So if I were to tell 5 things to my graduate self, first is, it's okay to get no. Like, I got a bunch of no's in my career, but if you want something and you work hard for something, you will get it. You will get it. If you aim for something and you're like, I need it, you'll get that. No matter how many times people will say no to you, if you decided that you want it and you just persevere, you will actually get it. It also means you need to work hard. One thing for me, it worked really well is if you pick one thing and got really good at it, you can stand out easily than if you were doing 10 things. For example, in my case, I did big data. In my early career, I did Documentum, right? And I did Documentum quite deep. So that got me not only job in Saudi, but also back in EMC, because I did it really well. So, EMC sold Documentum to customers, and they wanted me to be the consultant who will actually go there and tell customers how Documentum works and how to install. We actually could go and install Documentum. And so I used to be a specialist in Documentum. So being a specialist gives us, people in the countries like us, a chance to stand out, which makes people go an extra mile for you. So if you are really good at something, people would go extra mile to get you where they are. So, for example, I got a Saudi visa, right? And then I got my UAE visa from Saudi to UAE move. And also, it also helped me in getting immigration into Australia. So I moved in Australia. Being a specialist in big data got me a job in AWS. Being a specialist in analytics got me another job, or got me promotion in AWS, and sort of, be the person that actually did well for that service. I took care of a large swath of countries in APJ, and I did not shy away. I worked hard. I used to meet like over 100 unique customers. That's a lot of customers to see and talk to and help out. And basically that. So if you are specialist, it can actually help, especially from people from our country. But it doesn't mean it's the only way. I have a friend who's in a very good position, and again in Australia, and he happens to have learned the breadth really well. So he is managing teams and whatnot. So when you learn something, write and speak, so people actually know you are actually getting good, or you are good at something and you know some stuff. People look out for people who can help them in tricky situation. If you happen to be the person that actually know that specialization, they can reach out to you and they can potentially poach you also. So yeah, one of the things that AWS taught me was customer first, which means basically you need to care for your customer. I have seen, and I've heard, not seen as a lot, but I've heard a lot, that the work ethics are in our country is not as good as it needs to be, which means people do a lot of excuses. When they promise something, they don't deliver on time. They say something, do something else, do not show up at work. This is a terrible thing to do. So work ethics is going to define your career. If you said something you're going to do, you have to do that. In professional life, it's not uni, it's not your like neighbor or whatever. Like you can say something and you might not show up and not do something and you get away with it. Or generally in our houses, this happens, that people don't mind because of their family. In professional life, it doesn't work like that. So when you promise something, you have to deliver. You show up, you try yourself, but just don't give excuses on things. This is one of the things that is critical in professional life. So, and this is critical for your customers. So you have to actually show up for your customer first. You actually help, you go above and beyond for your customer without asking, because you pay it forward and it's going to come back to you. So that is what I'll tell, especially what I hear from a lot of people who have hired individual from our country. So be careful when you get into the professional lives. Do not do that. Commit and do something, because this is critical. You're going to lose trust. Trust is everything. We build from trust. AWS has 16 principles, which we call leadership principles. Do read up on that. And one of that is earn trust. Earn trust means, you if something is wrong, even if it is like, the service, if it's a customer signing a deal, and I know there's something wrong in that they're choosing the right technology, it's going to make AWS a lot of money, but it's wrong for customer. We will actually say, don't use that. We will kill deals if the customer's choosing us in the wrong way. And because in that case, we always get back the customer's trust. And we say, the customer then, come call us by name and say, you know what, I need this person on the project because I need this person's advice, because they trust you. And the trust gives you a lot more than you can imagine in the career. So the trust is the number one thing I would say, what you should strive for. And stay curious, learn. I will tell you that I was not, and I'm still not, the smartest person in the room. I'm generally not the smartest person in the room, but I can tell you I will probably be the hardest worker in the room, always, almost always. So that is one thing you need to strive for. Even if you think you may not be the smartest person, but you can outwork anyone. So work ethics, staying curious, learn. I joined ClickHouse and I questioned, I'm not the expert in ClickHouse, so I'm not gonna shy away from trying things. I will just give my best, everything. If there's a problem the customer asks, I don't know something, I'll say, you know what, let me get back to you, and then I'll probably spend my whole night dabbling with ClickHouse in that thing, and then come out and say, okay, this is how ClickHouse works. So this is now I have confidence that I can tell you the right advice, which means I'll earn the trust. So stay curious, learn, and and ask questions. Don't be shy. Don't be shy, because the people who think that they will look stupid by asking question, they'll lose a lot. I ask questions. I don't care like how you think about me, like, and eventually people will start, because eventually you will know probably more than most, and you will be respected. So even if you are asking stupid questions, they know you know stuff, right? So they will be like, no, it's not a stupid guy. He's asking questions. So that means we might not have done a good job explaining it. So do ask questions. Don't be shy. You know what? It's better to fail and look stupid in one place, and then probably do look very smart in 10 different places. So do ask questions. Okay, so can I just go to the AWS fundamental part? But before I go that, is there any question, like, about my journey or my experience before I get super techie into whatever, AWS? Any question? Yes, MBK.
Assalamu alaikum, sir. Hope you are doing great. I just curious about what's your process of learning, how you keep yourself up to date, or how you learn things in your today professional environment, and when you are a student. Like we as a student, we are now watching the YouTube videos or YouTube playlists to do so.
Yeah. There's no one place you can actually learn things. You do whatever works for you. So one thing that works best is trying it out. Okay. So you know what? I didn't plan for it, but let's do that. I will show you something. Or can I show you something very quick? Sorry, just give me a moment. This is the type of stuff that I talk about. Like, don't be shy. Let me tell you what I was doing before this call. So before this call, I was just wondering, can I show people that Amazon Kiro is a agentic ID, which means Kiro CLI, it's basically agentic coding system. You can tell it what you need to build, and it will build it for you. So I was wondering, like, you know what? I was curious, like, can I show the folks, or the students on the call, that with one single instruction, I gave it an instruction and I said, can I create an application? And it actually created an application. I'll probably show you later in the session. So I actually try things, and I don't shy away from it. Sometimes I will, in the beginning, you're like, yeah, you know what? It's really tough. I might not be able to build it, or I might not be able to understand it. But when you keep hitting the walls like that, you will eventually break through, and you will start, you will see, like, some of the basic things, like spinning up a database, spinning up a sort of, creating a small application, it will become easier and easier. Or download a new database and start, putting data in it. Well, it's easy. Or, download some framework to build an app and start building on it. If you start yourself, trying things out, you will get good at it. I used to be a person that would shy away from Linux. I would shy away from CLI. I'm pretty sure many of you guys are the same. You're like Windows people, and then you're seeing this terminal window open in front of you. You're like, you know what? This guy knows a lot of command. I don't, but I'm not scared. That's it. That's the only difference between you and me, is I'm not scared. I might say, you know what? I don't know a lot of, how to work with CLI and all whatnot, but I'll just go do it, because I know it's not going to put things on fire. You know what I'm saying? It's not going to cost me anything. It's just going to cost me time. I'm okay with that. So my way of learning is, yes, I read a lot. I watch a lot of videos whenever I find it. So I'll tell you one thing. Last night, I messaged my wife a link to a YouTube video, and she's like, what the hell is this? And And I'm like, don't worry about it. Because I landed into a YouTube video, which I was like, where do I store? Where do I store? Like, I have a link in LinkedIn, but I need to send it to someone. So, or I could send it to myself. WhatsApp, you can send it to yourself. But I was like, okay, you know what? Share it with somewhere, because I was about to sleep. I was about to go to bed, and I was like, you know what? I don't want to lose this video. So I sent it to my wife. But I know in my wife and my personal WhatsApp chat, I have this video, and I'll go back to it and watch it, because it was a Stanford Uni lecture for 2 hours. So that's how I learned. I just don't stop.
Thanks, sir.
Cool. Any other question? You can type in the question. I can see the chat window as well, just so you know. So if you're shy, you don't want to come on your mic and ask the question, you can ask the question in your in your chat window.
Hello. So, what mistakes will you advise us to avoid for building a better career?
I will not tell you to avoid any mistake, or embrace your mistakes. Basically, there's another principle in AWS called our right a lot. So we expect our employees to be right a lot. That's what we used to say, right? And at the same time, when people would join, we say, you cannot be right a lot before you being wrong a lot. So there's no mistake, sort of, I would say, avoid, because every mistake teaches you something. But the thing is, don't make mistakes over and over again, right? The same mistake. You should not be making the same mistake 3 times. Absolutely no. There is no room for it. 2 times is fine, right? 1 time is okay, good. You made a mistake, and you're like, oh, I'm not going to do this thing now. Okay, this is not how the database works. Oh, this is how I crashed the system. That's okay. You know what? It's okay. Speed is critical, so you have to fail fast and just carry on. To learn AWS, learn resources. You know what? If I give you a resource, you probably are going to think that this is the resource. There is no the resource. YouTube is really good. Once you start learning something, let's say you pick Docker. I would say pick Docker. Docker is a good place to start, because once you pick Docker, you can spin up things really fast, and you can download, you can run anything in your machine with Docker. So if you have Docker, then please go for it. If you can afford to get a Mac and get it's a very hard thing for a student, I will tell you what. So, but some people have that means to do that. So get a Mac, start building on Docker. This is easier in Mac than in Windows. But if you have Windows, get yourself good memory, and then sort of, start in Docker, spin up things, because in Docker, it's super easy. It doesn't actually change anything in your Windows machine. I haven't used Windows since 2014. So, but I know the Windows was evil, because something is installed in your machine, it can actually break registry and whatnot. I don't know if it happens still or not, but I'll tell you, if you have good memory, you can start Docker and start spinning up things in Docker, crash it, destroy it, delete it, spin it up again, and that's it. So that's that. Learn Git, GitHub or Git. Git is basically the source control, and go about building projects in Git. Checking in, checking out, because by the time you graduate, this is something that will be a muscle memory. So there are things that will help you move fast. So do learn that. All right. So the question is, we have multiple tools for big data. So we usually see is people recommending do this tool, do this tool. What is your point of view? Do whatever works for you, but I will touch about that in a moment. So go wherever you find your interest. I will touch on the big data in a moment. How did you figure out this domain? Was it you can go forth with it? How did you figure out this domain? Was it you can go? So I you need to, as an undergraduate, you probably are not in a position to pick things easily. Okay. But one thing I will tell you is you need to understand where you're good at. I was really, really curious about distributed systems, how I can build systems that run on many machines. And I tell people, like, after my undergraduation, I joined ITM system. When I used to come back home, I used to read a book called Distributed Operating Systems. My job did not ask me for it, but because I was like, I will do distributed systems, PhD in distributed system. That was my thinking. I'll do a PhD in distributed systems, so I will apply for a uni in the US in distributed systems as master's in distributed computing, and then I'll go on and be a PhD in there. So for that, I might not know a lot of things, so I need to know a lot of things. So I started reading this Andrew Tannenbaum's Distributed Operating System. It is an amazing book. I think still it's relevant. So I had a passion for distributed systems, but I carried on reading about it. Back in 2004 and 5, we did not have big systems like this. Like, we don't have the cloud and anything, so you can actually not try things. So you can actually just read and learn from the books. That's pretty much that. In 2007, Google released Google File System. I actually read that paper and I was like, oh, this is the stuff I want to do, because we were kind of obsessed about grid computing and distributed system at that time. So distributed system, big data, Hadoop is a distributed system. It's exactly GFS implementation, open source GFS implementation, GFS Google File System. So my passion for distributed system, Google releasing this GFS files, paper, and I read and obsessed about it. And I was like, okay, you know what, where can I do? In my master's, I wrote a paper that I presented in one of the conference. It was around grid computing, and then Hadoop when came in, I said, drop Documentum, I'm doing Hadoop, right? So that's how because I was passionate. So you need to find your passion. So figuring out this domain is my passion, will guide me to it. Cloud is a huge distributed system. Naturally, of course, it's in the same line of passion that I had. How do you decide which career is the one for you? I'm in the 6th semester, been trying different things out lately: data engineering, data analysis, quality assurance, development, etc. I do some project, but I can't figure out what to pursue. Whatever you're good at. If you think you can write really good code, like algorithms, then your computer science, like pure computer, like algorithms interest you, then you could potentially build, you should look for product engineering, right? If you are good at, learning how software engineering methodologies and project management works, and then you're probably a guy who would actually be able to help with program management, like delivery, so you might start learning, those PM certifications, like a PMBOK certification. I forgot even what they're called because I'm so the tech side that I don't know about what these are called. But there are PMO certifications that you do, like SAFe and whatnot. So there are mechanism of how actually run teams and all of that. So these are established practices, established professions where people are hired in numbers, who are hired just to make sure the projects are delivered in a really sort of controlled manner. So you could be doing that, you could be doing anything else. So if you're a data guy, you probably like, data crunching. You can query. SQL is the thing you enjoy. Python, playing with Python data and all of that is your passion. Then probably data engineering is where you need to go. Data engineering is a big field. I belong to that field, so I will tell you, that is also a big field. If you feel like, okay, I like computer plumbing things together, networking, and core, how VMs work, how do I spin up a VM, what operating systems need to be installed, how do you actually make operating systems secure, how do I make network secure, and all of that. So you're very infrastructure guy, so you need to learn cloud infrastructure. So because in cloud also there are so many things, and I'll touch that a bit later. For a student looking into break into cloud and AI space today, what is the most important foundational skill we should focus on building first? Learning. Fast learning is the skill you need to embrace. If you can learn fast, then that's the best thing, because things will change so fast. But start with any cloud. AWS is a safe place to start. Start learning various services in AWS, and then go from there. Yeah, I would just suggest pick foundations like what is compute, and I'll tell you about all of that in a moment. So I think it's a good segue to start going there, get that direction. How much time do we have left? Like 1 more hour? Is that what it is?
Yes, we have 1 more hour.
All right, so I will touch on that now, but I'll answer the last question. As someone entering in the workforce with a degree in supply chain, but technical certification in AWS, Azure, Python, I often see ERP roles split strictly between functional and technical. How can entry-level professionals successfully bridge that gap to build a career in cloud ERP implementation without being pigeonholed to one side? Both functional and technical skills are good to have. Functional, if you are a graduate if you're a business graduate, functional is a very good place to be. If you are a supply chain graduate, I feel this is a good place. There are a lot of people who actually can do the tech, but they cannot understand how the business works, right? So functional is a huge deal to know. So don't think that technology or techie, being a techie, is the only way. Functional consultants are paid a lot of money because they know how the tech works, and then they know how the business work, and then they actually bridge the gap. So they speak to the business in the language the business understand, and they speak to the techies how to implement things in a technical way. So these are super important skills, functional skills. I know functional consultants who are killing it in terms of, they're really, they've really done well for themselves, So I would say it is okay to be pigeonholed in someone if you're going to get really good at it. Pigeonhole yourself in functional, that's fine. I'm going to be the functional consultant for SAP, Workday. I'm going to be first functional consultant on Microsoft's whatever, right? I don't know, Dynamics or CRM. But you can't be that unless you're being put on a project. So if you're a professional, if you get hired and you get into those projects, then actually that's a really good place. So it's really hard to start in the specialization, because people will be like, we need a specialist who is already in a specialist. And then you're like, no, I'm a graduate. So this is going to be a chicken and egg thing and frustrate you a lot, but hang in there, because you're going to get your breakthrough like we did, like I did. And you know what? That frustration will be long gone, and it's going to be like sort of disappear in the past. So you would not even remember that you had that frustration period where you're like, people were asking for experience. I did not have the experience. And to be a specialist, I need that experience. So it's going to start. So hang in there and keep trying on that specialization you want to do. Until then, just keep the ball rolling for you. So that would be my advice. Life is very long. Even if it takes a year, 1 year is very long time. Frustration for 1 year is like really long time. But hang in there, so you will get a breakthrough. So if you stick to it. Yes. I will tell you about something about AI, and don't worry about layoffs. I will tell you, I have something in the end of the presentation. So I'm going to start AWS fundamental, right? So let's just get going. All right. So what is AWS? We told you about this. Cloud computing is basically something like electricity. You turn on, and electricity comes into your home. You pay for what you use. That is exactly what cloud computing is. Basically, the idea is, people used to buy a lot of servers, and then they would maintain the data centers, and then that's not their business. I am a company, I don't know, whatever, right? Peak Creams biscuits. I manufacture biscuits. I don't run data centers. This is not my competency. But because people, did the data centers by themselves for a very long time. That's a lot of companies do it. So the companies realize that they don't need to do this. They can actually give that stuff for some extra margin to someone else. Like, okay, it's going to cost me $2,000 for having my own server, but probably $3,000 to someone else running it. But then I don't have to build a data center and all of that. This is how AWS kind of pitched, and everybody said, nah, that's not going to work. Who will actually pay that extra money for the servers? People actually did, because they want to do really good and manufacturing biscuits, not running data centers. So that's how actually the idea worked. Now, AWS was very successful in the US, and they said, well, we can do it anywhere else. The world is so big. So they started, opening data centers more in the other states in the US, and then in the Europe, and then in the Japan, and then in Asia, then in Australia, whatever, right? So there are 36 worldwide regions, and where I am, it is AP South. Well, I think it's AP Southeast 4 or something. I don't know what is the number for Melbourne. There's a data center in Melbourne as well. So there's something called region, which is basically AWS say, well, you know what? In Sydney, I'm going to build a few data centers. I will have a lot of servers shipped there. I will have racks of servers. So these are like cabinets where you push a lot of servers in. And then there will be SAN, storage area network. Remember the EMC where I joined? Something like that. They actually buy a lot of SAN. They put it into that boxes. They connect the servers with the storage. And then, they need to connect to the customers. So they actually put a lot of networking hardware in there. And that's basically become the data center that they start selling to the customers. Now, but this is kind of, we don't need to know all of the details. What we need to know is AWS has a data center in Sydney. It's got 3 different zones. So because, what if my data center goes down for some reason, for any reason, like there was a power failure, there was a flood or anything like that. So they actually built 3 different places in the city, these data centers, and they connect with high-speed network, which means basically they look to you like a single data center, but they are actually 3 data centers. So when you spin up machines, you can say, well, one of my machine will run in AZB, and one of the machine will run in AZA. And if something happens to AZA, my AZB machine will continue to run, so long as my network knows that I need to go to AZB and AZA, which basically is the network, which is the VPC, with a virtual private sort of cloud. So when you create an account in AWS, you actually can create multiple VPCs, and then you could say this VPC should be across AZ1, AZ2, AZ3. It doesn't mean anything. It's a virtual concept. It's a record in the database. But AWS knows that when you're going to spin up machines, you can be spinning up machines in AZ1, ABC, and there will be some networks that need to go with it. Right. So that's basically the concept. And I am going to show and tell. So let me see if I can actually log into my AWS account as well. Oh. All right, console. Let's see if I'm logged in. I'm not logged in. I am going to just give me a second. I think it's good to show. Right. Am I on the call? Have I not disconnected? Okay. All right. So when you log into AWS, well, I logged out. So let's log in again. Right. So I'm gonna log in again. This is my username. This is my password. I logged in, and I entered somewhere which. So when you logged in, you are going to land here. This is AWS console. So I have EC2, which is my computers running or servers running. So I'm running a few machines here, right? Now these machines are running in what is called my VPC or VPC, my virtual private cloud. So it's not my computer, it is my personal account. So it's not my company account. So just so you know. So I have created 3 VPCs because I wanted to host 3 different types of application in 3 different sort of boxes or 3 different sort of separate things. And one of my these machines that I showed you, EC2s, VMs, like virtual servers. So these are the servers running in the cloud, and they happen to be in one of those VPC. So this is running in VPC 1, VPC 2, VPC 3, whatever, right? So they are running in different VPCs. And that's basically what this VPC that I was talking about is. Now, all right, so I'll just carry on explaining like that. Now, when you run a simple application, your user uses a browser, and then they actually want to connect to some application running on my VPC. So they will actually type in something. Let's say they type in whatever, www.google.com or whatever, right? Gmail.com. So there is a DNS resolution that needs to happen. Your browser is going to ask some specific servers that it knows that these servers called domain name services know that this name gmail.com is running in a IP address somewhere in some place. So it will say this is the IP you need to go. Once you have an IP, everybody in the like servers in the the net infrastructure in the internet actually resolves that to whatever location, like it's running my EC2 instance. So somehow the traffic lands into the EC2. Now, when it does that, it actually lands into what is called, application load balancer. Application load balancer is basically the thing that AWS has in front of the application that allows you to direct the traffic to either AZ1 or AZ2 machine. Like I could have two machines running AZ1 and AZ2. ALB will tell the user to go to 1 or 2, whatever, right? Depending on what your application is, or even Lambda, which I'll talk about in later. So that's how you basically land into EC2. There's a thing called CloudFront in as well. So if you are a website, you have a lot of images in there, you don't really need to host these in the EC2. You can actually push them out to CloudFront or the edge, which is where, the concept of edge is something like, where it accelerates the delivery of the content. That's why it's so content delivery network. So that's they're designed for. So even in Pakistan, when you go to gmail.com, a lot of the fixed assets, which means images or of the logo of the Gmail or various JavaScripts in there, they will already be in Pakistan hosted in some edge location. So when you go gmail.com, even though the server may be in whatever country, right, you will be served all the static content from the local edge. YouTube may have that. Facebook does have that. So I know these companies have the edge location in Pakistan, and they will serve, because that's why the traffic doesn't need to actually go to all the way to the US or wherever, right? So the CDNs do that job of accelerating the content, but some of the content really needs to be fetched from the database. So that is not hosted in the edge. That actually needs to be hosted in the database behind your application. So your application code will serve some parts, and some parts will be delivered through CDN. Now, you could have like really big files that you can store in S3, or it doesn't have to be big. It's just like, S3 is another type of storage, which is not the database store, but it's basically like file store. So if your application has images that if I uploaded an image, my profile image to LinkedIn, LinkedIn must be storing this in something because they're Microsoft. So I'm pretty sure must be Azure Blob, which is like S3 for Azure, Microsoft Azure. So that's how normally the application works. Do you have any question on this? And I'll tell you how it actually runs in the cloud. We pretty much know how it's now running in the cloud. What are the services? Like, DNS is a service in there. CloudFront is a service in there. ALB is a service in there. EC2 is a service. Lambda is a service. Database, RDS, S3 is another. So these are all the services that AWS offers to help you build the applications. Any questions? Any questions? Let me see. I am connected. So no questions. All right. So I will carry on. By the way, what you're seeing is Cloud AI design, which is where I have built this deck in. All right. So I'll carry on. All right. So now let's start with compute. The servers that I showed you in the console, they are servers running just like my my Mac, which I'm running, and I'm presenting this webinar to you. So EC2 is virtual machines that we rent from AWS, and if we don't use that, we can choose to give it away and stop paying for it. If we run it for the whole month, AWS will send us a bill. How do you connect to my server? Is the networking bit, which is the VPC and the subnets and whatnot. So if you are very interested in cloud infrastructure, networking, and all of that, you will be doing that in networking bit of how you connect to the application. If you're a person who actually like how operating system works and all of that, you will be the guy who will actually be configuring the EC2s and the images of operating systems in there, hardening it and whatnot. Then there is a concept of containers. So EC2 is a virtual machine. Containers are like tiny than a virtual machine. So basically within a single server, you can run many containers. In fact, you don't need to run machines. You can just run containers in AWS, which is the services called ECS, EKS, Fargate. So remember I was telling you Docker, you can actually download Docker in your machine, and you can run, Docker run whatever, and then you can actually install databases and whatnot. So people build a lot of applications in Docker, and when they want to ship these applications or run these applications in the cloud, they can actually spin up an EC2 instance and run all those Docker container within EC2, or they can say, well, you know what, I will just run containers in a service called ECS or EKS. So that's where containers can be run. But then there are applications who are built just on functions, which is Lambda, which is essentially saying this is my code that answers, that calculates, let's say, that calculates the value of pi. And whenever someone calls that, it actually calculates the value of pi, right? So I don't need a server for that. I can just write that code in Python and put it into a place in AWS called Lambda. So whenever my user hits that function, it actually returns the value of pi, and that's it. So I don't need to pay for containers running or EC2 running, and it will be just how many launches of that Lambda run. This will be how I build. So in containers world, how many containers are running 24/7? This will be how I build. Then EC2, it's the same. How many containers that I'm running, how many VMs I'm running, and this is how I will be built. So that's basically the compute, how you are going to run your applications, right? Now, application could be anything. It could be user-facing application. It could be data processing, like, data engineering, running the EC2 for processing data. It could be data warehouses, anything. So virtual machines is the core compute concept of container or the functions. All right, so that's how the compute works. I actually have told you all of that. So, as I said, EC2 is a bigger, you have to manage the hardware, network power, EKS, higher level service. So you need to basically, AWS manages the hardware, network power for you, EKS, hardware, even the OS, because in EC2, you will configure the OS. OS comes out of the box, right? But you will configure what libraries need to be installed in EC2. But in EKS, ECS, you run just a Docker container. OS is managed by AWS, and they give you the runtime. All right. And the Lambda, you actually just run your code. That's it. Everything else is managed by AWS. So if you don't run if nobody's accessing your code, you're not paying for it. So it scales to 0. So that also, this is actually really useful. If you can build all of your application Lambda, it's pretty good, because then you will only pay for what you use. And Lambda is pretty cheap. All right. So Amazon S3. Now, when you have application that wants to store or create the files and store the files in a long-term storage, then you can store it in S3, which means your EC2 can go away and S3 will not, because this is the long-term storage. It is not in the EC2 instance, it's off the EC2 instance, and it's stored in an object store, which can be accessed directly from your machine with CLI or from another EC2 machine. Or that means you can also use that for exchanging data between machines. That's why a lot of data lakes are built on S3. So you actually put a lot of data in there, and there will be many machines of EC2 crunch the numbers in those data lakes and access the data lake, S3 or whatever. You train a model, the model training, like, Anthropic, I'm pretty sure they use AWS. When they train the model, it actually runs in EC2, trains the model, and then the the final model, the Claude model, will actually be exported into S3, from where it's going to be loaded in those big GPU machines to serve you the AI. That's how things work. S3 is the means to exchange the data. Now, EBS is, so that's exchanging the data. But what about like disk of the server? It's virtual disk. It's called EBS, Elastic Block Storage, which means your operating systems run when you create files within your operating system, you can choose to store on a root drive, which actually is the boot drive, or you can store an EBS volume that can potentially be detached from the from EC2 and attached to another EC2. So you can actually create a disk, which will be like your C drive, D drive, E drive in your Windows, just like that. One of the drive will be in the EBS, and you will store data in it. And you can just kill your machine and then have that drive sitting there attached to another machine later. So this way, people build solutions that actually turn off in the night, wake up in the morning, attach the drive again, and carry on. EFS is a file system. Again, Elastic File System. It's like NFS. Generally, I see like a lot of customers use S3 or EFS, but if you are coming from certain Windows software or some legacy software, they will actually need EFS file system. So you actually use that. And then there's Glacier Deep Archive, which means your S3 data sitting in your S3 costs you $25 a terabyte. If you want to not pay that $25 because you're not using the data, it's just sitting there, nobody's accessing it, but you don't want to delete it, you can actually keep it in a archive tiers of S3, which will cost you a lot less. All right. Any questions so far on the storage? So this is the type of compute, this is the type of storage, and then how do you connect these things? It is the networking. So remember I was saying your application comes to the ALB and lands into one of your machine. All of that is basically networking. So you create VPC, which is a virtual private cloud, which essentially means this is a place, this is a secure network where whenever I spin up machines are attached to this network, so only the authorized traffic is going to route into those machines. When I say authorized traffic, it means anyone accessing anything on the internet, it will not actually land to that because I made it private. And I will open that doors to only the people I like or the IP addresses I want. And that's where security groups would come in. So security groups is the way to unlock some of the openings in those networks, so you can route the traffic in. And there are many different ways. Security groups is just one way. Customers connect their data centers with AWS Cloud. So they could be running private or hybrid cloud, which means they bought from some local cloud provider. So they could be data centers locally, other than AWS, that offer a cloud service, private cloud services, which means I'm a company that I'm really good at infrastructure. I'm not AWS scale, but I can provide Melbourne wide customers access to cheaper servers and networking and whatnot, which will be not public cloud. So those servers can then be connected to AWS through special sort of telecoms access, or I forgot even the name of the things. Connect or something. I forgot. So yeah, you basically create a pipe that is dedicated between the data center and AWS. You purchase the bandwidth between there, and that's how that traffic actually moves to the AWS. And then on the other end, in the AWS, you say, this is the VPC that traffic should land to. So it's not just a security group. You actually can do a lot of networking in there. DNS, domain names service, basically Route 53 is one of the service in there that actually resolves the name, let's say whatever xyz.com, to your EC2 instances. So you actually configure Route 53 that will route your applications to or internet traffic to your application or within the network. So you could be running EC2 instances. One of the applications is called ERP, right? So if other machines or other servers need to access ERP, they will just go to Route 53 and say, I want to access our ERP. And then Route 53 will give the IP address of the EC2 that is running the ERP. So Route 53 will resolve the name of the applications to the IP addresses that they're running in. It could be EC2 containers or Lambda. And then this is how different applications talk to each other. And then, of course, CloudFront, I told you, look, which is the edge location, which will serve the static content much easily. So this is pretty much high level of what the networking essentials. Now, if I run this EC2, right, and it needs to access S3 storage, will it have any permission issues? Yes. Everything runs on identity. So we create IAM role, which is Identity Access Management Service. You create roles, which is virtual construct. It's a record in a database. It's not a physical thing, but EC2 is attached a role. So I'm going to say this EC2 is given the permission of this role. So that means anywhere EC2 traffic goes there, EC2 can send in the traffic headers something that identify itself as that role. So for example, Route 53 or S3 service receives a request from that EC2 instance of mine, which has in the header this information that I am this role. I will check whether you have got the role. So I'll check, the S3 will check whether you have the role or not. Well, you have the role, good. Now, what does this role can do? Can it store files in S3? Oh, well, yes, you can. So that means that EC2 can write to S3. That's how everything in the cloud works. If you have to spin up a database, your IAM role needs to have the access to spin up a database. So as I log in, remember I just logged in to AWS. I am logged in. This is my role. I am an administrator in my account. So I actually logged in as administrator. So remember, I clicked here. This says admin access to my AWS. And that's how I actually logged into my AWS. Even if I was using CLI or, terminal, let's say here, I could access AWS using CLI, and I can log in to AWS using certain credential. It's going to challenge me. I'm going to ask permissions and whatnot. And then my user will be logged into CLI, but I will have some kind of role, which is what allows me to spin up these machines, spin up this network, and go and spin it. Because when I'm admin, I can do anything. So this is my S3, right? So if I go to S3 service here, this is my S3. I might have some buckets. So here I have a few buckets that have stored some data. So if I go here, well, look at this, it's got a zip file in here. So these are my buckets, and this is, will have some other data like Terraform state, which means I was deploying something and it's storage state in here. So again, the idea is either I'm logging into the console, either I'm running an EC2 instance, I will have to have some roles. So if I go to my EC2, I don't know, will I be able to see the roles, but let's see. Security. See, this is the role. This is the EC2 role. So this EC2 instance accesses S3. It identifies itself as whatever, epoch, EC2 role, whatever, right? And what this role can do, let's see. This role can actually access a lot of things. So it can access secret access. And it can also, so this is where it actually accesses some secrets or passwords. That's that, and I think that's it, because this thing does not need to have any other permission. If I this is the only permission policy that I have created for this. So that means my role cannot do S3 or anything else. My EC2 can only do so many things, but there will be other roles that I will use to access stuff, right? But anyway, so that's basically the identity. Identity is a very important concept in cloud, so you must learn that. So remember, so it's saying non-negotiable, give minimum access. So remember, I gave only access to password. So I actually allow that EC2 to access the password, and then it will take some other role, which I will not show you what, and it can do more. And then encrypt everything. So everything is encrypted on the disk using, using a KMS key, which is a whatever encryption concept. I will not go into the details here. But then anything that is being accessed, AWS provides you things to watch. CloudTrail tell you who has changed the role, who has access, who has logged in. CloudTrail tell you everything. Guard Duty is another service that actually tell you if there's any security issues in your service. Security Hub is also for that. And then once your application there, what else can I build? I can actually do a lot more things. So I can store data, and data can be stored in databases, which could be operational. Operational, which means a database, like, I'm using an application and it's storing my username, password, and whatever transactions, or it could be a to-do list, and all the to-do list is in a database. And there are many databases. Depending on different scenarios, you use my Postgres, MySQL, DynamoDB, MongoDB, and whatnot. And they could be analytical databases, which are like, large data processing systems. So ERP, and a large company runs an ERP, which captures everything, all the sales, all the, all the employees' payroll and whatnot, everything, supply chain, inventory, orders, whatever. All of that data changes every single day, because, you send the inventory from your warehouse to a store. That inventory needs to be tracked. So that information needs to be updated. So the databases that track inventory will update things. And the store, when it receives it, it will accept that, and then there will be some databases records that will be created in that. So these are like operational data, right? Now things will get sold. Then the POS, or point of sale, will have the transaction that will say, well, this item, whatever, a shampoo or an oil or whatever, right, gets sold, and these items got sold. So all of that information needs to be stored in that transaction system. Everything is in many different databases. So that's why you need the analytics databases to bring everything in one place and say, well, this is how our inventory moved. This is how the inventory sold. In this store, we made sales of $5 million. In this store, we made sales or $2 million. And this is the most popular product in this store. So, and it often runs out of stock, so we should be doing better by stocking more next week or next month. That, all of that information is the analytics of your business, and you need to do that in special systems called analytical databases, like Redshift. If you're in GCP, BigQuery. If you are in AWS or GCP, you could use things like Snowflake or ClickHouse, where I work. We are also an analytics data warehouse. So you do your reporting or analytics in those analytics systems. Any questions? Am I too deep into things, or are you guys okay with that level of detail? I can actually go up and go down also. Is that good level of details?
Yes, it's pretty
Thumbs up.
Yeah, it's perfect.
Okay, perfect. So just, if you have any questions, I am happy to go deeper or, shallower. All right, so now we have databases, and we know how these, companies run the systems in the cloud, and how our operational databases work, and how the analytics happens, and why analytics needs to happen. So we know everything. If anyone talks to me, I will probably don't know how actually I'm going to build this, but I know, well, there should be an EC2, there should be a database service, there should be storage somewhere, there should be EC2 or whatever, right? That's networking. And if those two POS terminals and warehouse machines need to talk to each other, they need to talk to over the network and all of that, everything sort of kind of, you can start imagining. All right, so when you choose an operational database like ERP, as I said, POS terminal, that will probably be RDS or relational database, basically, which means it will allow me to create records in multiple tables, and there will be relational tables, like, there will be a product table, there will be a sales table. In the sales table, There will be an ID of the product, the quantity and whatnot, and whatever the price and whatnot. So that will be a transaction. There will be a sales order, and then within the sales order, there will be sales item or something like that. All of that will be kind of your point of sale or transactional system. Similar, the warehouse system will work completely different ways, or your logistics systems will work completely different way, but they will need relational. But then you could have Aurora, which is also exactly like it's also relational, but it's basically much higher enterprise grade guarantees and a little better in terms of reliability and scalability as such. So they're very similar. It's just that Aurora is kind of like a equivalent of Oracle, if you were to say in the legacy sort of world, or even like today's world. Oracle is a very sophisticated database. AWS used to have Postgres used to be open source, and people would be like, yeah, you know what, it's not enterprise grade. So Aurora is the answer for enterprise grade, and from AWS. And a lot of customers now have realized that, you know what, Aurora or RDS is good enough for us. But then there are solutions which require really fast lookups, which means I'm running Instagram, right? And Instagram, people want to watch. I'm an influencer, and I'm actually posting a lot of videos. So you follow the influencer, and then you actually type in their name, and then you want to hit their profile page. And as soon as you hit the profile page, all their reels need to be listed. And that is basically a key value lookup. So you have a key, which is this influencer's handle, and you want all the reels, right? And that is very good, very fast, done by DynamoDB. It's a very fast lookup. So there are solutions. If you do it in Postgres, yes, you can do it, but it is more relational. It is more complex questions. So join the transaction or product table with the sales tables and the items tables and show me a view. DynamoDB is more like, give me everything about one thing. Like, give me my profile. So if I go to my LinkedIn profile, there is a key value for lookup there, where it says, fetch a profile of this individual by this key, which is the ID of that individual. Those types of workloads at internet scale need to run in milliseconds, like 1 or 2 milliseconds. The reason is, if you are going to take 200 milliseconds, you're going to be like, 200 milliseconds is really fast, right? Why is it crazy? Like 200 milliseconds is saying it's slow. It's slow, trust me. Because if your CPU is stuck for 200 milliseconds fetching something, you need so many CPUs to handle internet traffic. So your database can do in 5 milliseconds, then 200 milliseconds, then technically you are about 40 times faster than the other database, right? And just because of that, you probably need 40 times less CPUs, and when I say CPUs, essentially it's CPUs at the end of the day, but it's compute. So you need 40 times less EC2 machines to run this thing, or whatever the database is, right? So your database DynamoDB doesn't work with machines, but just imagine, like, it's the cost efficiency you get. If your system is fast, it's going to cost you less most of the time, unless that fast requires a specific type of hardware that is very expensive. That's not what we're talking about. For example, the really fast databases like Elasticache. These are like crazy fast. They're like microsecond fast, right? It's not a millisecond thing. It's like microsecond thing. It's saying under a millisecond. So those things run in the memory. So now if you're Instagram and you want to host everything in the memory, you're going to need gigantic memory, right? That will cost you gazillion. Yes. So where I said, if it was a fast, it will be cheap. Not really. If it is in memory, it's not going to be cheap, right? So fast is not always cheap. But if it's a system like Dynamo, it is going to be cheap to run this thing. But if you are writing a lot in Dynamo, not doing a lot of read is fine. If you're writing a lot of data in Dynamo can be expensive as well. So not that you should not store large volume of data. It's basically if a single record is really big, you're storing files in Dynamo, not a good idea. Absolutely not a good idea, because DynamoDB was designed for really key value pickup, lookup really fast, not sort of, storing a whole lot of things. And there's also a thing called DocumentDB, which also is kind of like MongoDB. So again, key value store. These are called NoSQL databases. When I say key value document is a NoSQL. In memory is called NoSQL databases, right? So it could be relational NoSQL databases, but you use that for the purpose for you want. So as I said, relational systems or key value system or in-memory system. Why would you want in-memory system? Something like likes. When someone is watching Instagram Reel, they just press like and they want to up the counter. That data needs to be in the memory so that everybody knows that how many likes of that video. So it's a key value, but it's a tiny data, right? So likes or shares, or that 4 or 5 thing that pop up on the right in TikTok Reels or Instagram Reels. I don't even know what it is, shares or likes and whatnot, right? Yeah, whatever. So that tiny data, it's very good. Sometimes people even store searches also. When you go Google and search for restaurants near me or something like that, Google actually have, or you search for some term like Claude was released and everybody was searching Claude Opus, right? Google will keep that in the memory because it needs to serve really fast, and they are happy to keep that search result in the memory because they will return in microsecond. That means they can handle. So let's say if they're returning in half a millisecond, right? That technically means in a single second they can serve 2,000 requests within a single second. With the single machine, they can serve 2,000 requests, and that's a lot of requests. 2,000 users saying whatever Claude Opus and then getting the results in microseconds. Everybody's happy, the search results are super fast. But Google is putting them in the memory because it works for them. So internet scale, you have to design system based on what kind of data system you're looking for. Any question? Because this is very key thing on running internet scale or any application for that matter. All right, I'll carry on because we've got 20 minutes more. So SQS, and then how applications will talk to each other. Like, how the warehouse system was kind of like delivering things and to the store, and the store inventory needs to be updated. They could be talking to APIs, and they could be talking through, street or eventing system. For example, someone created an account. If you created an account in a bank, then there is a process that issues you debit cards. So account creation service will just send a message to a central eventing system, right? Whatever that is, right? And that eventing system is subscribed by many. So people are, not people, systems are listening to that, listening to that service and then say, you know what? Ali created an account. Is there something that I can do for that? As a customer, yes, I can create a debit card. So because I'm a debit card service, so I'm going to create a debit card and send a debit card, or create a debit card, whatever, and send a message back to another queue, which says, issue Ali a debit card. This is the address. This should be the name of the card. This is the name of the card, a number of the card. This is the name of the card. This is whatever the secret code and whatnot, right? And then there is this other system that is looking into specifically debit card publishing queue, where they actually pick that up, print that, and send it out, right? So this is how actually systems work. Systems don't directly talk to each other, because what if some system was in the maintenance? So when you don't want the systems to start failing because one of the system that they depend on is going down, like for example, if I'm doing a maintenance on debit card publishing system, that the one that prints the cards, then the whole upstream systems are going to stop working because one of the chain is broken, one of the sort of one of the element or one of the block in the chain is kind of broken. So that's why a lot of systems are designed through these queues or events, and that's where there's a whole lot of services in AWS that offer this eventing system. A queue, which actually is a message that puts into the queue, and then there's someone else who's listening to the queue. It's more only one sender, one receiver. Which, remember, I told you, like, debit card creating service will create the debit card, but the printing service will be something else. But they will be talking through a queue. But then there's PubSub, which is basically one-to-many, which means the first one, someone created the account, then I actually went to PubSub and then say SNS, someone has created an account, his name is Muhammad Ali. And then there will be many things that can be doing things like under this debit card service. The other one is an email service that sends me a welcome email saying, thank you very much for opening your bank account. Then there will be another service that will allocate some employee as my account manager for this bank. There could be many things. So that's SNS for you. Event Bridge basically is similar to that. Right. So, and step function is basically workflows. API gateway is basically kind of like a gateway or a front door to your services, which will allow you. So if you have an API, you print an API gateway in front of it, then you can do something like rate limiting. Oh, I will allow only 10 requests. So in ChatGPT, you start talking to ChatGPT too much. It says, you know what, get out of here. I will allocate you only 10 requests in a minute. Don't do beyond that and wait for next 10 hours or whatever, right? That's rate limiting. And that's how they actually do it, when they put things in the front and they're rate limited. Right. This is basically how a request path will look like. Remember, I was talking to you about things. So user can come gateway through API gateway. I will rate limit. If you were allowed at call, then Lambda will be called, and I'll store things in DynamoDB. But if you are doing asynchronous, you can actually have something that, an API is called, account created, an event bridge gets the event, then it lends itself into a queue, which is going to be processed by, credit card publishing service, and they will send, and they will create a credit card, and then there will be an email published after that. So this is how the application works. Now, analytics, the reporting part. Remember how everything was working, but everything is working in their own silos, and there's no central point to say, well, how many products were sold in the whole region? No, we don't know. We have to go and what was the delay between the warehouse and blah blah blah. Everything has to be put together in a central system or lake or warehouse for you to be able to do all that decision making. So that's where the analytics come, because we're collecting so much data that people started sort of deciding to not put everything in a single database, but they started putting things in what is called data lakes. There's also another reason not everything is structured, so there could be unstructured data. People are creating posts and whatnot, and even if you're an enterprise, your customers are talking on social media, you're listening to social media, you're receiving requests in emails and whatnot. So there could be a lot of things that happen that is unstructured, which has to be captured and stored for the analytics. And that's why data lakes kind of were born. So they do everything, not just structured data, they do unstructured data, and they are generally for very large volume. And when you are talking about data lakes, you're talking about building systems on something like S3, the object store I was talking about in the beginning, where S3 became the thing to share data. It's actually one of the biggest system to share data in S3s are called data lakes. So they share data between enterprises. So this is where we collect the data, we massage the data, we combine the data from all the warehouse transactions and the backend and whatnot, and give you nice reports and nice structures so you can actually call. Now, if the data was structured, or even if it's unstructured, you actually bring that into structured or semi-structured format and load it in data warehouse, because they're designed to run reports really fast. So they are fast joins. They will help you run reports really fast, or process a ton of data, the whole day worth of data super fast, and create a new table that has all the things you need for the report. And that's where your data warehouses would come in. generally the difference between a database and a warehouse is because they are columnar, which that means is when you store a database, when you store a record in the database or 10 records in the database, a single record is stored in a contiguous location, which means they're all stored together, right? My name, my birth date, my address, my whatever, right, account number, everything is stored in a single location in the disk. And the second record will be right next to it, and then the record after that. So if someone wants to run a report, I have to read all the rows, even though I'm just interested in, let's say, the account value. What is the average account deposit amount in my bank? So I want to take all the account values of all the customers, but then I have to walk through all the rows. This is row store. So that's dumb, because you could have just read the whole column, but no, now you have to row, because it's data stored row by row. You have to walk through the whole rows. Columnar changes that. It actually stores, every column is in a single file. So someone says, hey, what is the average amount of the account deposit values in my bank? I'm just going to read the whole column file for that account value and do an average. That is super fast, because I'm not even reading anything, because IO, or input output reading from disks, is the worst thing, or S3 is eventually at the end of the day is disk. So when you read from S3 or these disks, it's slow. So you just read the file or the data that you need to process, and that's where the columnar structure comes in. So this is the difference between the databases and data warehouse. Data lakes are like objects, files, right? So they're like a bunch of files. Warehouses is taking those files, putting them into structures that is easy to work with. Even though some of the files, like Parquet files on S3, are still columnar. So you can actually go and read, even in the S3, you can just read the columnar data. So don't get me wrong, data lakes are not just files. They can be files and anything else, and columnar structure as well in there. And then there's Lakehouse, which is basically saying, I'm going to store these files just like the data warehouse does the columnar files, and also have all the bells and whistles, but still sit on S3. So that is the Lakehouse. So it's saying, I'm going to give you everything the data warehouse gives you, and everything the data lake gives you, which is the high volume, unlimited space, but still efficiency of the data warehouse. That's called Lakehouse. Now, right. So now, if you're working with analytics, you want to build reporting, right? You can create reporting or data warehouses with hyperscalers like AWS, Google, and whatnot, or you could create like Snowflake, Databricks, which is also two of the very popular, data warehousing or lakehouse solutions out there. And then there are up and coming, like I work for a startup called ClickHouse, which is huge and is the fastest analytics data warehouse in the world. And so eventually you will see that ClickHouse or one of those names will, come into the camp too, which is becoming the big data companies. Right. So every cloud has full analytics stack. By the way, AWS is not the only one. AWS is a bunch of things which has the lakehouse or warehouse or streaming. Did not even touch on the streaming. I'm not going to talk about it right now because it's just going to take some more time, or search or whatever. So Google has the equivalent. Google has GCS, which is like S3. Google has Big Lake, which is like Data Lake. Google has streaming or PubSub, which is called PubSub. Google has BI solutions. Google has search solutions. So does Microsoft. All right. I have my opinions. Microsoft may not be as good as the other ones, but you know what? You have that tools as well. And as I said, they could be specialist tools. Like for example, for reporting, these companies are designed are built for data warehouse. So the cloud providers build so many services. They may not be very good at these things, but these solutions that you see on the screen are really, really good at their stuff, which is data processing, data warehousing, data lakes, and whatnot. All right. I am going to skip that. I'm going to skip OpenSearch as well. And I'm going to skip probably ClickHouse as well. But ClickHouse is supposed to be the fastest data warehouse or in the world. It is used by a lot of companies like Netflix, like Anthropic, Claude, ChatGPT. It's used by Tesla. It's used by Walmart. It's used by Microsoft. It's used by, you name it, Cloudflare, which runs half the internet. So why? Because it's super cheap and super fast. Remember I told you, like, if your speed is super fast, you could be super cheap as well. That is what ClickHouse does. It is amazingly fast. You can actually have a billion row and you get milliseconds answer. And you're like, how is that possible? Well, that's possible. You can have billion rows and you get a millisecond answers. So I'll leave it there. So that's the kind of software sort of, there are coming up and coming data warehouses offer, and which is why they're becoming super popular. Right, so I'm going to skip that. I'm going to go to the AI, which is why we have very little time. What is an LLM? Large language model. Basically, like Claude or ChatGPT. Basically, there's a GPT model behind it. ChatGPT is just a wrapper on top of that. So when you ask a question, and ask the model behind the scene, and that model is what OpenAI has trained or Anthropic has trained. Anthropic calls their model Claude. OpenAI calls them GPT, and other labs call it something else. Amazon called it Nova, Google called it Gemini. So, but what are these? Basically, what they do is when you give it a text, it actually predicts the next word. That's it. That's exactly what it is, right? But it's so good at predicting a word that it actually makes a lot of sense in almost always. And that's how that's what it is. So if you start typing the quick brown, the model will predict. Well, I have seen so many places where when there's the quick brown is written, the fox is the next word that needs to come. So it actually adds fox. And then it reads again, oh, the quick brown fox. What is the next word that needs to come? Well, I have seen a lot of the time jumps. The highest probability of the next word that needs to happen is jumps. So it says jumps and then says the quick brown fox jumps. Well, what is the next one? So remember, it doesn't even have a memory between its own prediction. It's actually looking at the same thing over and over again, and it's predicting the next word. So technically, so when it responds you in any of your question, like when you ask ChatGPT or if you ask Claude anything, it comes back with something. That's it. Like basically, it doesn't know who you are and anything. It's the wrapper. It's the application or the Claude application or the ChatGPT application that takes back the request. User is asking this question. This is what is the context of your session. And then it says, if the context of the session is like this, and user asks this question, what is the next word that needs to come? And it just starts predicting the words. That's it. It's exactly the same thing. So, but it happens to have trained on so much data that it actually knows a lot of stuff. And it was clearer in 2017 or 18 of the world that the bigger the model is, the more the memory is. So you will hear about 17 billion or 107 million now, or 300 billion parameters or 500 billion parameters or something like that. 1 trillion 1 trillion parameters model. This is the kind of a measure of how much memory that it has, or when I say memory, it actually how much it can actually remember things. It doesn't have memory about anything, but it remembers a kind of. It doesn't make sense, but yeah, that's what it is. It doesn't have operational memory, but it remembers things. So it's kind of like I know, but how I don't know. That's kind of thing. So I just know that. The pen writes. Who told you that? I don't remember that, but I know pen writes, right? That's the kind of thing it is. So if you ask it, how did you know pen writes? I will not be able to tell you because I learned it so long ago that who told me pen writes? I don't know. I've been writing with pens for all my life. That's how I know pen writes. Anyway, so that's basically my naive way to explaining how actually LLMs are kind of behave. So, right. So there are so many models out there, and there's another concept that there is, which is called embedding. The idea is when people at Google has actually done it first time probably, and that when they actually gave a lot of, they came up with this idea that You can model things such as like the language or the word into mathematical constructs or arrays of numbers that will allow me to measure the similarity between different words. Right? For example, if you give it, so they train a model and then it actually reads all the words and says, well, king, queen, prince are very similar words, so I'm going to give them numbers very close to each other, right? And the apple, banana, orange are all fruits. They are very close to each other. I'll give them some separate set of numbers. So I'll start allocating numbers to it. Let's think of this way, right? Such that when you give me any words, I know that what word it is. So I have a way to map that word to those mathematical structure or array of numbers, such that I can actually then find you other words similar to that. That is also LLM's way of predicting the next bit, right? So first they take the words and convert that into these embeddings, and then they actually go about doing other things, right? So this way you can also say, well, I'm searching for banana, or I'm searching for pancake, and it will return me all the pancake mixes and maybe the flapjacks, because in some part of the world, flapjacks is the same thing as pancake. So there's a concept of embedding. That's how images are searched. So images are turned into vectors and vectors are searched. So that's that. And prompts are basically, as I said, prompts are just words that you put together that is likely to get you the answer, because that is the way the model actually predicts the next thing. And Amazon offers SageMaker, which is a machine learning service, and Bedrock, which is the LLM service. Bedrock offers LLMs, and that's how you actually do that. There's this thing called retrieval augmented generation, which is basically saying, fetch me some data from a database and then give it to the model and then let the model answer. So it answers from your data rather than answers from its knowledge. So you say, here's the data of my company, answer me this question. So it doesn't actually answer from a memory. I think we're on time, so I'm just going to close it out super quickly. But I would just tell you like one last thing. This AI thing is the biggest change our industry is going through, which might make you think that, you know what, I am new. There's a lot of people who actually know that, and then AI is laying off a lot of people. So juniors will have not a good place to start. That is not correct, because think of it this way. Everything that I've learned in 20 years, model is much better than that. So I might have experience, but my knowledge is captured already and given to you as a model. So even you can answer things as probably as good as any 20 years experience person or 25 years experience. You don't need that person to in the office. So there will be a time where models will get so good at it that people will be like, you know what, we can just hire junior people who actually cost less and are more motivated to work than the more senior people. There will be few seniors and a lot of junior people. All right. So it is not your disadvantage. It's actually your advantage. It's how you use that. So if you are the person that walks in the room and says, you know what, I can outwork anyone because I've used AI so much in my chat GPTs and whatnot. I know how exactly it behaves. I on average work 2 to 3 hours a day talking to Claude. I'm telling you right now, this is how it works. And the more you use the models, the more you actually know how to get best out of that. So this is your advantage. It's not something that you actually think that, that is in your disadvantage. So, be bullish about it, learn AI, build things that probably was not possible. As I told you, a moment ago, I gave it a prompt and it actually built an application. So if I actually go to my, localhost 8,000 over, never mind. So it actually did the application within a few minutes. So the terminal that I created and says, you know what, this is the application, and it's actually running in the EC2 instance as well. So if I checked it, which we don't have time for, but it is going to be running in the local as well. So yeah, this is actually very, very easy to build application in, just one session. You can actually build a whole application that is running in the cloud for you or in your local instance. So I would just say, embrace it. One thing I will ask you to do is download this Kiro CLI. AWS gives you like 50 credits, but if you have an AWS account, it gives you 500 credits free. 500 credit is good for you to learn how to build applications in the cloud. So do try this Kiro. And I think you guys like Muhammad, you and the other folks should be able to help these guys get some credits from AWS, right?
Yes, we get some credits.
So do you want to talk about it right now?
So basically, we have a lucky draw to give out credits as well. So
Okay.
are you done with it?
Yeah, I'm pretty much done. Like, so I was just telling you, like, this is what I built, and it was supposed to be a survey application that it's not running anywhere. So, but the idea is like, you can build application in just about like, a few minutes with Kiro. So but see, it's saying it's working. So if I go here now, hopefully it's working. There you go. This is an application running in the EC2 instance. So it has created an EC2 instance just now. Kiro did it. I did not ask anything. This 13 something, whatever, 1354, 144, 97. This is the instance. So if you look at this, webinar feedback. So this was supposed to be an application where I create this. If you scan this QR code, you should be able to log into this application. So if I say, how was the session? And I say, good, bad, or very good, right? I don't know. Like, let's send this question. Now, do you guys see the QR code? I don't know if it works or not, but let's try. Give it a try. Continue to the site. My name is Ali. Yeah. So you see, this application was something I just built with Kiro. How's that? Nothing. I just typed a few minutes ago. I typed it. I need an application that does that. And then I need to deploy it in EC2 instance. It asked me, like, do you confirm I'm doing this thing? I was like, keep on doing it. And then in the end, I did not know I will finish it. But by the time it finished, it's already up and running. That's how you can build application. You don't need to know how this works, but just you have an idea, you build it. Awesome. So I will stop sharing and I'll let you guys close out. Sorry, I actually overran, but I hope I actually motivated at least a few of you to be able to sort of, go build things.
Yeah, session was very insightful. Thank you for the time. You shared a great knowledge today. Like from starting from your experience, then coming to cloud, starting with basics of what is compute, what is storage, what is networking. You covered a lot of today that I haven't covered in like past 1 year. So that was really insightful session.
Awesome. I'm glad you liked it. So yeah, thank you everyone for attending. And I hope, I wish you guys good luck in building things. And one last thing is maybe, you guys can potentially connect me on LinkedIn. You guys have my address. I think you have shared it on LinkedIn. So Faizan, you have shared it. Afan, you probably shared it. Or
yes. Yes, I'll share it in the community as well.
Right. All right. So there you go. So you guys have my LinkedIn address. If you have any question in your career now, future, I'll try my best to answer the questions. And please be please be mindful that I might be busy in sometimes, and so I might come back to you a little later. So don't mind if I delay the questions answering, but I'll try to come back to everyone. Yeah, but don't ask me for job because I might not be hiring.
Well, thank you so much for joining. And all the participants. I hope today's session was really insightful. One last thing before we go, we'll have an exciting activity. We'll have a lucky draw. Whoever gets his chance gets $25 of credits of AWS. I'll just be sharing my screen in a while. So, yay, let's go. Spin all. We have Aris. Aris, Amin. Are you in the meeting? Aris. I don't think Aris is in the meeting.
He is.
He just sent a he sent
Yes,
he just sent a message.
sent a message.
Congrats. You just received $25 of AWS credits. I hope it will be helpful for your learning. Move. Now we'll have one more spin. Smile, Fatma. Smile, Fatma. Are you in the meeting? I don't see them. We'll keep spinning until we get 2 winners.
Okay, so one more disclaimer: you need a valid AWS account in order to redeem the credits.
Rekha G. Charles. Please let me know if any one of them is in the meeting or have they joined.
She is in the meeting as well.
Malaika Naveed. Are you in the meeting?
It seems she is.
Oh, congratulations. You have also received the $25 of credits from AWS. Suleiman, can you share your slides again? We'll just conclude. We'll just conclude everything up.
Okay, 1 second.
Thanks for joining. So we have also announcing one slide back. So we are also announcing our team. We are opening the team registrations because currently we were only about 5 to 7 people who work on this event, and I guess we need some more people who want. It's not just that you arrange events. We'll have proper hands-on workshops for the team as well. We'll have project-based learnings. So you guys can scan the registration form link. I'll share it in the group as well. Those who want to be part of the team.
Okay, I think so. That's it. Aman, please also share the link in the community and all the relevant groups of the area.
I'll share the link. Also, we have one compulsory thing. You all will get certificates before 12. And the final thing of this first meetup for learning will be an evaluation form that you guys will fill. I'm sharing it in about 5 minutes in the community. Please fill whatever you liked in it. Hope you understood what you did not understand, so that it makes us choose better speakers better topics for your guys' learning. Basically, this session was an overall overview of each and every detail of the cloud. Thoroughly explained about 80 to 90% of the things, different domains. Like, he did not stick to one specific domain. He's explained a lot of different things. So a lot of you might have been confused that, oh, that's so much knowledge. But basically, we wanted to start with covering everything in the first session. Then we'll break it down into different categories. Like, if we get more people interested in machine learning and AI side, our next session will be only based on the AI. And if more people are interested in data engineering side, data analysis side, databases side, our next sessions will be according to that, whatever you guys fill in the survey forms. So do fill the forms.
And you can also pitch in your recommendation for speakers. And if you know someone is your relative or your friend or colleague is working in a cloud related role and you think that he or she would be a great addition or would make up a great speaker, you are more than welcome to share their profile with us and we would definitely consider.
And once again, thank you all for joining. Jazakallah. Stay curious, keep building, and we will see you in the next episode. Good luck, everyone.